The one time I don't check, I didn't do my little check window, then my audio didn't work. So let me do my check window just to confirm that everything is clicking. I can see my subtitles. Optimize the video. Here, that looks decent. Zoom. Join. That's fine. That's good. Don't connect. Okay. Stay as a participant. Get it. Please go. Thank you. Okay, cool. All right, gentlemen. Let's see. Let me check the battery on this. Battery is better than this one. I'll leave it for now. Those are over here. Oh. Hey, Google, change the light color to white. Hey, Google, change the light brightness to 100%. All right, gentlemen. Let's see. So, yeah. So what we're going to do today's just going to be a makeup lecture for Monday. Normally, you know what? Just now in the moment, because what I was thinking I was going to do was like just do Monday's lecture today. But I know that anything that I want to say is already in my recordings. So I'm going to assume that either you've already listened to it, and if you haven't already listened to it, I know you can watch it later. So I think that instead, what I'd like to do, I think I want to still go through the homework, and I'll break into like lecture and explanation as we go. So that way we can still kind of go through some of the homework, and we'll talk about whatever it is that we need to talk about again as we go. So I think that's what I'm going to do instead, if I can get this to work. Like I say, everything is kind of being a little bit haywire today. As far as attendance on Monday, if I saw any signs of life, I essentially gave you credit. There were only a few that didn't hit the number that I was looking for as far as the quiz. So, and then, but if you were completely MIA, if I didn't see you like either in the Zoom trying to check in, or if you didn't complete that quiz, then I had to mark you as absent. And what I'll do is I'll just add this homework to these lecture notes, so then you can kind of use both. Okay, so let me pull up the homework because I feel like that'll. Now, low key, another thought that I had, when I was reviewing the quizzes, I was like, maybe we should review this quiz a few times because it's a pool. I want to go here. So that's why I was like, yeah, let me try to go do some examples. I feel like that might serve a little bit better. Because again, instead of just repeating things that you already have access to. So I think I'm just going to move forward. Here. Okay. Let's see. This is this one. 9 a.m. Let's go. Okay. You can see I watched too much Encanto. Let's go. Let me see. I think so. Week 12, section 2.3, right? So we had our attendance quiz again. I really just used it to take attendance. It was unlimited attempts, and it was only available during class on Monday, right? So to get max credit, you need to pass that, and then anything below passing, then you were kind of at my mercy. Again, as long as I saw signs of life, then I usually gave everybody attendance credit on that day. But if it were no show, no call, MIA, then I didn't have a choice, right? Okay, so let's look at the homework actually. Allow. And we'll do our attendance polls and things of that nature. They have changed the format. Interesting. How many questions? We got 24. Okay. Give me a random number between. Go. All right, let's start with question 19. Minimize the list. That's fine. It'd be nice if they kept the numbers while it was minimized. I think that would help. And what I'll do, I'll zoom in like this a little bit. So, but that's okay. Interesting. Interesting. Yeah. Actually, I have it saved here. Playlist music. Yeah, I'll just use that one. Let it go in the background. Okay. And as always, if you have questions, feel free to either unmute yourself or type in the chat or the Q&A. I am monitoring the chat and the Q&A, so I will make sure to get those questions addressed before we part ways. Okay, so this is section 2.3, dividing polynomials and rational zero tests, okay? So this section is heavy factoring intensive, right? So, you know, you kind of need to have your factoring game on lock. If you need a refresher on factoring, one, it should come up in the lab, right? You know, I think everybody has a custom lab through Alex. I would assume that factoring would be a portion of that. Another source you can go to get some practice on factoring, if I haven't stated already, which I probably have. So, you have a question? Is in Blackboard, when you click on the box link, you're going to see several folders. One that says syllabus, notes, another folder that says handouts. In that folder that says handouts, you'll find 2 documents on factoring. One document is an overview on how to approach a factoring problem. So you want to definitely check that out. And then the second document is a copy, a PDF scan copy of an entire chapter from like intermediate algebra devoted to factoring. So it'll go over all the, pretty much at least 90% of the factoring scenarios we'll come across in this course. With examples at the end of each section. So that's all in Blackboard, and you can find that there. So let me see, find all rational zeros of the polynomial function given below. So let me kind of walk through this as if we were doing the lecture. This is called, the technique here is called the rational zero test. And so what we're going to do is generate a list of possible rational zeros of this polynomial. Now this list that we generate, these are not the actual rational zeros. What we're saying is that within this list, if this polynomial has any rational zeros, it's going to be somewhere in this list that we create, right? So we're going to generate this list. After we generate the list of possible rational zeros, the next challenge is finding the actual rational zero. The hardest part, I feel like, is finding that first zero. Once you find the first, then it kind of flows from there. And so one technique that we have to quickly find the first zero is basically just look at the graph. That'll help save a lot of time. Right? We have graphing utilities, yada, yada, yada. Right? So we have tools and resources that we can use. So let's start by getting a copy of this guy. Okay. So hopefully that was okay as far as the explanation. That's essentially what I would say during the lecture for this. Okay. We'll take it, I guess we can take it about here. Let's cut that off about, I guess about there. But that's good. All right, we're gonna drop you right, y'all. Like so, like that. Boom. Okay. A pen and a list. Okay. So the rational zero test is gonna be our P over our Q, where P are the factors of our constant term. So our constant term in this case is the -3. So factors are, we want to go through all the factors of -3, basically things that multiply to give us 3. So the factors of P are going to be plus or minus 1 and plus or minus 3. So we kind of got a little bit lucky with that constant and only had 2 factors. And then Q are the factors of our leading coefficient. That's going to be the coefficient in front of the term with the highest power. All right, because sometimes they mix up the terms. You want to make sure your powers are in descending power order. So our Q comes from the factors of 12. All right, so the factors of 12, let me see, plus or minus 1 and 12, plus or minus 2 and 6, plus or minus what, 3 and 4. Okay, So these are all the factors of 12. Let me rearrange this. Right there. This, like that. Like so, like that. Okay. So then now what we're going to do, we're going to take all factors of P from our constant term and combine them with all the factors of Q from our leading coefficient without repeats. So if we have a repeat, we don't include it, right? We just include one copy of the repeat. So like that'll give us plus or minus 1. So I'm doing 1 over 1, 3 over 1, all right? So then we get plus or minus a half, plus or minus 3 halves, okay? A third, okay, I'm kind of running out of space, so I'm going to drop down. Or let me move this actually. Okay, so we did 3 over 2. So now we do a third. So plus or minus a third. Okay, 3 over 3 is 1, so we already have that. That's one of the duplicates. We can do a quarter. Okay, we can also do 3/4. Okay, we can do a 6. 3 over 6 is a half. We already have a half, so we don't want that duplicate. 1/12. 3 over 12 reduces down to 1 over 4, which we already have. Okay, so, and again, all I did, if you didn't catch it, I said 1 divided by 1 gave me this answer. Then I said 3 over 1 gave me the next answer. Right? And then, I did 1 over 2 to give me this one. Then I did 3 over 2 to give me that one, right? I just did all those combos all the way down, okay? So now this list that we have at the end, these are not the actual zeros. We're saying, again, for this original polynomial, if it has any rational zeros, they're going to be somewhere in this list, okay? So again, I'm going to use my trusty dusty rusty. Which device? I think I'm gonna use my graphing utility. I started to use Desmos, but I felt more confident with my Texas Instrument, so I'm gonna use that instead. Come on, man, my device is taking a sweet time. Let's go. Oh man, it is struggling today. It's not responding for whatever reason. Maybe I need to suppress that. There we go, finally. Okay. Oh, it's taking a sweet time. Okay, so now let's reload and refresh. Okay, so first I'm going to get a copy of the original. I'm going to go to my y equals 37 x squared. Yeah, that looks good. Plus 2x minus 3. Okay, so then I'm just going to look at the graph to see if I can see some of the x-intercepts. Okay, it looks like -3. See, and I was kind of hoping that 1 would be 1, but it doesn't look like it crosses at 1 or -1. So based on this, it looks like either a -1/2. I'm going to try -3. I want to see if -3 is one of my zeros. Because again, the most challenging part is finding the first zero. Instead of doing guess and check, like we could have started with 1, we probably would not get a 0. We could have tried -1. Instead of doing guessing and check, I was like, well, just let me look at the graph. And it looks like it crosses the x-axis when x is -3. So I'm going to use synthetic division to confirm or deny whether -3 is one of our zeros. Okay, so we're gonna put -3 in our chair. That's our test. Do we need any placeholders? 3, 2, 1, 0. We don't need any placeholders, so we can just take the coefficients. All right, so we got 12, 37, 2, and -3. So I'm just, again, I chose -3 because I looked at the graph. It looked like it crossed at -3. So I'm going to use synthetic division to confirm or deny whether -3 is indeed a 0. So we're doing synthetic division. So we didn't need any placeholders. Every power was accounted for. This first term just comes down. Okay. On a diagonal, we multiply. Vertically, we add. So 3 times 12 is going to be a -36. If we add, we get 1. Diagonal, we multiply. We add, we get -1, 3. -3 plus 3 is indeed 0. 0 is our remainder. So since we got a remainder of 0, that confirms that -3 is one of our zeros, okay? So then, since we started with the degree 3 polynomial, at this stage, we're now at what's called the depressed equation. We're now going to be at a degree 2 polynomial. So this is going to be 12x squared plus 1x minus 1, okay? And then, you can kind of keep in mind that if -3 is our zero, x minus -3 is going to be our factor, all right? So the original, right now, we have it down to this stage, okay? Now, we could either, now we just want to find the zeros of this quadratic. We could either, use the graph, and try to identify zero. Since it's a degree 2 or it's a quadratic at this stage, we could also use quadratic formula. We can do completing the square. I think I'm just going to try to factor the trinomial, right? And at this stage, it's a trinomial, so I'm going to try to factor it. If I were to factor this trinomial, I'm looking for two numbers that multiply to give me, hopefully you're thinking, -12, not -1. I know it's tempting to say the -1. It would only be -1 if the leading coefficient were 1, right? But because that leading coefficient is 12, which is not 1, we're looking for two numbers that multiply to give us -12 and add to give us 1. I think that's going to be 4 and -3, okay? 4 and -3. So, style. All right, that's fine. So what I'm going to do, that 4 and -3, I'm going to rewrite that middle term using the 4 and the -3, okay? So from here, off to the side, I'm going to use what's called the box method, now that we have those two numbers. In the upper left-hand corner goes my leading coefficient, or my leading term, sorry. The bottom right goes my constant term, which is this guy. Now, for that green +1, again, I'm going to use those two numbers that we just found, which were, I'm going to rewrite 1x as a plus 4x and a minus 3x. Notice that 4 times -3 is -12, and 4 plus -3 is +1, okay? So that's why I chose those two green numbers. So then from here, now I feel like once you get this little box method down, then, it's easiest to factor in this form. So from the top two boxes, we can factor out, let me see, what color have I not used? The greatest common factor looks like 4x. From the bottom two boxes, it looks like we can factor out a -1. The left two boxes, the greatest common factor looks like 3x. And the right two boxes, it looks like it's just a +1, okay? So now, if we take the 0 that we pulled from the graph, and we confirm with synthetic division, coupled with this box method, now what we're saying is that g of x, the original, in completely factored form, we have this x plus 3 times 3x plus 1 times 4x minus 1, okay? Let me do a quick FOIL to make sure that factor works. 4 times 3 is 12x squared, minus 3x plus 4x is indeed positive 1x. 1 times -1 is indeed -1, all right? Okay, so then if we FOIL this all the way out, we should get back to the original. Now that we have the original in completely factored form, now we can find the zeros, all right? If we basically set it equal to 0, so we set each factor to 0, long story short, our zeros are going to be, it looks like we have -3, -1/3, and a +1/4. All right, so when we looked at the graph, I was like, remember I said it didn't cross at 1 or -1? Notice that all of these rational numbers are in our list of possible rational zeros, right? So, and we can check that these actually work. If we plug them into the original, come on. If we plug them in the original, these should all generate 0. And let's confirm that before we submit. Okay. So what we're going to do, because we already have the original, we'll kind of zoom out just a little bit. I'll go a little bit more. So because we have a copy of the original in our equation editor in our y equals, I'm going to call on it. If anybody needs the details on how I'm calling this, just let me know, but I can walk you through it. So we want to evaluate g when x is -3. Again, the result should be 0. I'm going to recall. I want to evaluate this when x is a -1/3. We should get 0, okay? And then we want to evaluate this when x is a positive 1/4. And we should get 0. Okay. So we confirm that these are the zeros. We have a degree 3 polynomial. We have all 3 zeros. Again, we have at most 3 zeros. So we can be confident in this result. -3, 1/3, and 1/4. This one. Okay. All right. Come on, let's go. Off. Okay. All right. Let's go. Come on. Thank you. -3, -1/3, comma, and a positive 1/4. Cross our fingers. God is good. I feel like there should be questions. I do feel like that was a little intense. I don't really know what you all experienced on your end. I'm hesitant about giving answers when questions are not asked, right? Oftentimes, if we're not having the experience that we're like, or if something isn't sinking in, we're just not asking the right questions. If we're not asking any questions at all, then how do you expect to get an answer? I could give you the answer, it won't register because you're not asking the questions, right? So if I'm giving answers with no questions, I'm just talking outside of my neck, right? It's not until you guys start prying and asking questions and digging, working together, working with tutors, making use of my office hours, using the Ask My Instructor, that's when it's going to sink in. You have to, if you're not having the experience or getting the responses that you like, you might not be asking the right questions, right? So maybe you got to ask some different questions. And if you're talking to somebody, if it's me or whoever, and they're not saying what you want to hear, you might be talking to the wrong person. You might have to find somebody else to talk to. And one of my former students taught me that. Okay, so let's do another one. Let's do some more. Let's go to question 5. Thank you. Let's go to question 5. So 1, 2, 3, 4, 5 should be this one. You are struggling today. We go like this. Maybe this will help it. Or I've completed that many, but resume. Question 5. Is this a little bit better view? I mean, we can see what we need to see. I'll work with it for now. Let's zoom in just a little bit. Okay. So this one asks us to use synthetic division to find P of K. Okay, so I think this is an application of the remainder theorem, right? Okay, so the remainder theorem, because that was from Monday, which you guys didn't have. Let me pull a copy and I'll just walk you through it. I'm not filling this. I'm going to minimize this. That's a little bit actually. How do I want to do this? If I could switch these around, that would actually work for me. Right, okay, and let me do like this. Right. So I'm pulling the copy, and I'll explain the remainder theorem right now since we didn't meet on Monday. There we go. Yeah, so I guess I just need to kind of reboot everything. I know this a lot, but I hate to do it during class because our class time is so precious. And it eats up a good amount of time having to reboot stuff. Okay, so the remainder theorem, the abridged version. So, if x minus a is a factor of a polynomial, then the remainder is equal to f of a. Something like that. Like if we have a polynomial divided by x minus a, then the remainder after synthetic division is equal to f of a, right? So, for instance, if we wanted to evaluate, so like our remainder is going to be equal to p of 2, right? So in other words, what we're saying, if we do synthetic division where we put 2 into the chair, our remainder is going to be p of 2, right? P of 2 is going to be found by the remainder, right? Okay, so let's do synthetic division, right? In this case, 2 needs to go into the chair. Do we need any placeholders? Right? We got 3, 2, and then 0. Yeah, we need a placeholder, right? We need a placeholder for the power of 1, right? So the first coefficient is 1, then it's -6. So because the power of 1 is skipped, we need a placeholder, and then the constant term, which is this guy, okay? So again, the remainder theorem is basically saying when we do synthetic division, we get a remainder. That's going to be the original function evaluated when x is 2. All right, so let's do the synthetic division. Instead of plugging in 2 and getting an answer, we can do synthetic division, and the remainder has this equality going on. Okay, so again, on the diagonal we multiply, vertically we add, we multiply, we add, we multiply, and our remainder is what, 6 and 3, which is a -9. Right, so that's our remainder. Right, so the remainder there, basically what we're saying is that P of 2 is going to be equal to our remainder in this case, which is -9. So instead of evaluating the function when x is 2, we just did synthetic division. The remainder was -9, so that's going to be the function evaluated when x is 2. Okay, so let's see, -9 should work. Now again, we could check it. I'm just going to plug it in, for the sake. So we got -9. Okay, brighter. We're not getting any brighter. Okay, that's fine. All right, so let's generate. Let's go to question 9. Okay, that is a lot more smooth than the other one. I will give him that. So here we're asked. Let me see. I know it's blurry. I've got it expanded as best I can, and I can't clear that up. I don't know how to. We have like the best internet that they offer. Use synthetic division and factor theorem to determine if x minus c is a factor. Okay. So synthetic division and the factor theorem, right? So if this x plus 2, let me see if I zoom in like this. If this x plus 2 is a factor, then when we do synthetic division with the potential 0, we should get a remainder of 0. If it's not a factor, then the remainder won't be a 0. Okay. Let me get a screenshot. Let me get a copy. And basically what we're going to do is synthetic division and interpret the result. Okay. Like this. Okay. Use the image. I had some, I don't know why my dreams were so weird, but I had some weird dreams. I had dreams like we were in an Attack on Titans and we were getting attacked by giants. It felt like Attack on Titans in hindsight. So that was weird. And it didn't feel weird in the dream. It's just when I woke up and I thought about it, I was like, man, that was a weird dream. I had another dream. I was like, me and some friends were like exploring some realm. It felt like South America or something, like in the jungle. But we were all like somehow riding in like a mini Jeep. I don't know how we all fit, but we were fitting in it. It was weird. I woke up and I'm like, what are these random dreams? Oh man. And then like, I don't know. It was just a lot of weird stuff. Okay. Oh, let's do like this. Add a page. And I want a Ruby one. We'll start there. Synthetic division. Okay, so if we're going to do synthetic division, again, we put our potential 0 in the chair. So if x plus 2 is a factor, then that means that -2 is our potential 0. That's the item that goes in the chair. Okay. Do we need any placeholders? It goes 5, 4, 3, 2, 1, 0. It looks like every power is accounted for, so we don't need any placeholders. So then we take the coefficients. The coefficients are 1, -1, -3, 3, -4, and 4. Let me see. All right. Okay. So then if we do synthetic division, the 1 comes down. Diagonal, we multiply. Vertically, we add. We multiply. We add. We multiply. We add. We multiply. We add. And it looks like we indeed get a remainder of 0. Okay. So then it is a factor, right? Because we got a remainder of 0, then we can say that x plus 2 is indeed a factor of that polynomial. Okay. So is this a factor? We would say yes. Random generates. Okay, we can do question 1. That's fine. So I guess I'm not going to show it there. Completed. That's one thing I am missing. That would be nice, but that's okay. Because I don't want that open like that. All right, here we're asked to use synthetic division to find the quotient and remainder when the first polynomial is divided by the second. So another thing about synthetic division, we can only use it when we're dividing by a linear binomial, right? So it's linear, meaning the highest power is a 1. Binomial, meaning there are 2 terms. If we're divided by something that's not a linear binomial, then we need to do polynomial long division, okay? So if we're going to do synthetic division here, our potential 0 goes in the chair. That means that 2 is our 0, 5, 4, 3, 2, 1, 0. Okay. So we don't need any placeholders. I think I'm going to just take my notes on the side here. I'm not going to like screenshot it. I'm just going to leave it side by side. This. I might have to zoom out for this to work. You can at least kind of see it. I would like to zoom in, but it won't show if I do it like this. Okay. I think this is question 1. I'll just put it in circle like that. This comes from section 2.3.1. Okay. All right. So if the x minus 2 is our factor, the potential 0 will be a positive 2. We already determined that we don't need any placeholders, so we can just take the coefficients. So the coefficients are going to be 1, 2, -6, 1, -1, and then -1. Should be 6 of them. 1, 2, 3, 4, 5, 6. Okay. Again, the first number just comes down. If on the diagonal we multiply, we add, we multiply, we add, we multiply, we add, we multiply, we add. 9 times 2 is 18. We get a remainder of 17. Okay, so since we started with the degree 5, we're finishing with the degree 4. So this is going to be 1x to the power of 4 plus 4x cubed plus 2x squared plus 5x plus 9. Okay, with a remainder of 17 over x minus 2. So again, that purple line that I just wrote, that's called the depressed equation. It basically, it drops by 1 degree, right? We started at degree 5, we dropped it by 1 degree. We're going to say x to the power of 4 plus 4 plus 4x to the power of 3 plus 2x squared plus 5x plus 9. Okay. And the remainder, okay, and the remainder is 17. Okay. We got right at about 10 minutes remaining. So let's try to get some more in there. Let me kind of minimize this for a little bit. Generate. Let's look at question 10. So I think we did 9. I think this is 10 here. I'm not going to show me. Okay. All right. Use synthetic division and the factor theorem to determine if x minus c is a factor. Okay. So that means 3 goes in the chair, 5, 4, 3, 2, 1. We don't need any placeholders. This is kind of a repeat of what we just did. I'll just go ahead and do it. It should be fairly quick. We need another page. Okay. And this is question 10. This comes from 2.3, question 21. So 2.3, question 21. Okay, so if x minus 3 is our factor, then that means positive 3 needs to go in our chair. Again, we already determined we don't need any placeholders, so we'll say 1, 2, -8, -16, -9, and -18. Okay. I know my lines are crooked, but it's okay. So we're going to bring the first number down. Diagonal, we multiply, we add, multiply, we add 21, 5. What time is it? We're good. 15, 6, 18, and then we indeed get a remainder of 0. So then is x minus 3 a factor? We would say yes, because when we did synthetic division with the potential 0, we got a remainder of 0. Okay. Generate 22. Let's go to question 22. Right there. Find all rational zeros of f, then if necessary, use the depressed equation to find all roots. Okay, so first they want all the rational zeros, and then they want us to find all roots. Because some of the roots might not be rational, right? So, all right. So this is question 22. This is question 22. More than likely, this will be our last one. Our f of x, we got x cubed minus 5x plus 2. Okay. All right, so let's start with the rational zero test. Let's do our p over our q. Okay. P are the factors of the constant term, which is plus or minus 1 and plus or minus 2. Q, oops. Q are the factors of the leading coefficient. In this case, I like it's is just 1. So then our list is already created for us. We got lucky with this one. I have a small list. Okay. So if this polynomial has rational zeros, now 1 is fairly easy to test. 1 minus 5 is -4. That doesn't work. That doesn't give us a 0. Let's try -1. That's going to be a -1 plus 5. Positive 4, that doesn't work. Let's try 2. 2 cubed is 8. Minus 10 is -2. 2 works. It looks like 2 is a 0. Okay. So now, if we want to confirm that 2 is a 0 using synthetic division, 2 goes in our chair. Do we need any placeholders? All right. Hopefully you're thinking yes, right? Because we skipped x. We got x cubed. We got x to the 1 and x to the 0, but we don't have x squared. So we're going to need a placeholder there. So the first coefficient is a 1. I'll do the placeholder in purple this time. So placeholder for x squared, and then -5 and 2. Okay. Again, the first number just comes down. 1 diagonal, we multiply, we add, we multiply, we add, we multiply, and we get a remainder of 0. Okay. So we found a 0. So then let me see, if we started with the degree 3, at this stage, we're now at degree 2. So this is 1x squared plus 2x minus 1, okay? Can that be factored? Can we find two numbers that multiply to give us -1? Ooh, and add to give us 2? Nope, I don't think so. So then now at this stage, we might either do completing the square or the quadratic formula. I think that I am going to use the quadratic formula, right? So quadratic formula. Okay, so quadratic formula, x equals, I see the time I'm wrapping this up. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. Okay, so that's the quadratic formula. So then in the above line, our A is 1, our B is 2, and our C is -1, okay? So then -2 plus or minus the square root of 4 minus 4 times 1 times -1 all over 2. 2 times A, which is just 2, okay? So then -2 plus or minus, double negative is positive, 4 plus 4 is an 8. Let me see, 4 times 2, so that's going to be 2 times the square root of 2 over 2, okay? So then it looks like it's -1 plus or minus the square root of 2, okay? So the original 0 we found was 2. So then all of our zeros, it looks like we have 2, and then -1 plus or minus the square root of 2. So we have, in this list, you can find our rational zeros and all of our roots, or in other words, all of our zeros. 2 of the zeros are basically not rational because they have the radical, and we use, once we got it down to a quadratic, we use a quadratic formula in this instance to find those 2 remaining irrational roots, right? I bet you I said it somewhere else. My bad. My bad. It'll sink. Okay. All right. So let's go back and answer the question. Let me see. Okay. I guess it's just the 1. So we can put all of our zeros here. 2, comma, we got -1 plus or minus the square root of 2. Check your answer. All right. All right, gentlemen. So at least we got to go through, and I think we touched on the meat and potatoes. It's as far as section 2.3. The key moment. It's still a good idea to use my recording and watch the corresponding recording for the section just to cover your tracks, so you can go through all the details. Again, today I decided to just do the homework because I know that you have access to it. So instead of reviewing something that you already have access to, let's try to do something a little bit more dynamic. Are there any burning questions before we go our separate ways? Going once, going twice. Let me check the chat real quick. Yeah, I think we did several with the P over Q, the rational zero test. Again, the P comes from the factors of our constant term. Q comes from the factors of our leading coefficient. And we want to do all combinations with P over Q without repeats, right? I think we had a couple of examples where, when we did P over Q, we got some repeats. So we only included 1 copy of those duplicates. And then so once we have that list are our possible rational zeros. In other words, if our polynomial has rational zeros, it's going to be somewhere in that list. Now, instead of doing guess and check to find that first 0, I just looked at the graph and saw, okay, where does the graph cross the x-axis? What's my x-intercept? Okay, so it looks like it crossed at -3. Let me confirm or deny uses of that division, whether -3 is or is not a 0, right? So then we did synthetic division. We got a remainder of 0, so we confirmed that it was a 0. Another thing about synthetic division in these zeros, sometimes the zeros occur multiple times, right? And so, sometimes you have to use that same number and pass it through synthetic division again. If you get another 0, then that means that 0 occurs multiple times, and you can kind of keep doing that until it doesn't work. So it just takes a little bit of effort and exposure, digging, curiosity, collaboration, for this. Aside from that question in the chat, if there aren't any other burning questions, we're going to go ahead and end the session here. I want to say that this Sunday, right? Exam 3 becomes available, right? So what that means for next week, on Monday, we'll do a review. Like if you start your exam early, like on Sunday afternoon or whatever, you can ask questions about the exam during class. Like, it doesn't have to be proctored or anything like that. You can ask questions. We can work on your exam together. It's just, again, it does me no good to give answers if questions aren't being asked. So if you ask, then more than likely I'll say what I can. I might not get the answer, but I can get you over any hurdle, and we can work on stuff together. So that's up to you. If there aren't questions, then I'll just do a review and go through as many questions as I can. So that'll probably be Monday, and then Wednesday, probably an attendance quiz, right? Anywhere from 5 to 10 questions that you can only access during class. Yeah, that'll probably be Wednesday. Okay. All right. So with that, we'll go ahead and end the session here. And from one beautiful mind to another, have a great weekend, gentlemen, and we'll meet back on Monday, same time, same place for the next installment. All right, guys. Good luck with everything. You know how to reach me. Take care and peace. We got some outro music this time a little bit. Not feeling it, but it's okay. All right, guys. I'll go ahead and make a copy of anything you saw me writing available. Take care. See, finally dropped. There it is. Let's go. Okay. Work out for this. Upload. All right. So, all right, guys. I just made a copy of any notes that you saw me taking. It's available. And have a great weekend, gentlemen. Take care. Peace. Let me check and make